everybody. I'm Dr. B. I'm going to be demonstrating to you some basics of SPSS, and I'll be showing you how to go through some of the steps. I know a lot of you are very new to the to this whole interface on how to analyze data, but some of the skills that you learn in this course and in this tutorial you'll actually be using in a lot of the public health research that you do in the future. So with that in mind, let's get started. I wanted to show you the difference between data view and variable view. This is over here data view. It shows you the raw data. In this case, this is a fictitious HIV data that I created. It has 4 columns and 20 rows because it has 20 data sets. The first column is the subject ID, and then age, the HIV status, 1 being positive for HIV and 0 being negative for HIV, and then gender, 1 being male, 2 being female. So there's another way that you can look at the data, and that is in variable view. So in variable view you have, as you can see, 4 rows that is actually representative of the 4 different types of variables, four different variables that we have that you saw in the data view. So the first one in the first row is the subject ID, and as you can see, the type that it is a numeric data. It could have been any different types of data. It could have been strings. So if it, say, it had some sort of wording in it, then it would have to be string data. But in this case, it's numeric data. You can actually also give the maximum number of width that it has if you want to turn it down to 7 or 6 or 8. It doesn't matter. Now the decimals, sometimes when you have some sort of data like height, weight, BMI, you might need decimals. But in our case, all we're looking at is HIV status and gender and things like that. So we're not really concerned with that. So now we can look at the actual data, now that we know the basics of what the variable view looks like. And it's very convenient to come back to this variable view, because if you needed to change something, you can quickly do so, and that will alter it in the data view. So let me, for instance, give, even though age doesn't have a decimal, let me give a decimal. So let's change it to 1 decimal. So now in the data view, as you can see, they're showing 1 up to 1 decimal place. So that's always convenient. So let me change that back to 0. And then let's go to analyzing some of the data. This is really the main part of what you are going to be using, data analysis. When I do complicated data sets, when I analyze complicated data sets, many times I end up using some of the other menus, and they're very useful. But for starters, I think it's very important to know this menu really well. So descriptive statistics is what you did in your shared activities in this unit, and also what you had to apply to your individual assignment. And I know a lot of you had some difficulties, which is why I'm making this tutorial, in order to make it a lot simpler. So when you have a data set, the first thing you want to do is you want to know what you have. What's the information that you have? So this is a simple HIV data set, and I already told you what are some of the variables that it has. So from this data, oftentimes we're limited with the data that we have. So we can't ask questions which are outside of the scope of the data that is provided. So for instance, you can't ask something like, what is the relationship between socioeconomic status and HIV. So I can't ask a question where if I want to find out that do lower socioeconomic groups have a higher HIV rate, I can't find that out from this data because I don't have any information about socioeconomic status. So that is what I mean by I'm limited to the data that is available to me in the data set. However, I can pose a question, and this is something that you were asked to do in the individual assignment. From this data set, I can pose the question that is there a relationship between age and HIV status? In other words, is there a significant difference between in age group between those that have HIV and those that don't have HIV? We can definitely ask that question because we have both age and we have HIV status. So what in this unit, what we're starting to get used to doing is looking at the data and trying to formulate questions which are appropriate for the data set. And this is a skill that will take time to develop, but I wanted to see in this unit how well you were able to do so. So with that in mind, and of course that's not the only question you can formulate from this because you have gender information, so you can ask a more complicated question in that in females, is there a difference between is there a difference in age group between those that have HIV and those that don't have HIV? So you can add levels of complication in the questions that you ask, and that's the beauty of quantitative analysis of numeric data. Now that we've made the transition from qualitative to quantitative analysis. So moving forward, analyze descriptive statistics. So the first menu, the first choice is frequencies. So under frequencies, you can actually get a good idea about what type of frequencies you have in terms of males versus females. So in terms of when you're just looking at frequencies, it makes no sense to have a central tendency in that situation because I mean it can give you some information, but for the most part it doesn't really make much sense. So I'll just continue on that one, and it will automatically display the frequency table. And you can do bar charts. Bar charts make sense because, and if you want to do frequency versus percentage, in terms of this, probably a percentage might make more sense. So we can do a bar chart and look at the percentage of gender and take a look at what file we come up, what graph we come up with. So let's wait for it to run. It's running it, and depending on the speed of your computer, it might take a little while. And now you have not only a breakdown in terms of a numerical breakdown, but you also have a percentage breakdown. And that percentage breakdown, you can see it's 1, which represents males. You have a 65% rate. You have 65% of the respondents are male, and 35% of the respondents are female. So this is one of the graphs that I know in your individual assignment question it said what types of graphs are appropriate. So this was possibly one of the graphs that you could have shown that was appropriate. Now, I know you all analyze different types of data, but I'm using this as an example so that you could use to apply in your specific scenarios. Okay, so moving forward, now looking at frequencies again. Now, I wanted to show you that where some of the central tendency might have been appropriate. So in this case, mean and standard deviation are things that are pretty important. So the mean is of course the average of all of the values that I have in the sample. Now, what you should understand conceptually, this is only a sample of a whole population that it represents. This is not the whole population, and it's only a representative sample. So in this case, the mean and the standard deviation are what's appropriate. And as I look at your assignments, I'm going to take a look at how you resolve that issue and how you were able to apply that. But this is where the mean and the standard deviation are the most important. Now, you could, because central tendency, the median is also sometimes important, you can also do that as well, show that as well. And then if you still would like, you can do a frequency table, or in this case, because it's more of a continuous variable, it's not categorical, then that might not make as much sense. So again, there's really no need for a chart, but sometimes a histogram to see if there's a kind of a normal distribution on a histogram that might reveal some things. So in a continuous variable, you might make the argument that that's something that's necessary. But again, as I'm trying to show in this, it's open to interpretation what types of charts are necessary and what's not necessary. So this shows kind of the distribution of all the different age groups, and the idea is as you draw more in the sample, as you have more in the sample, as it comes closer to the population, then you're going to have more of a normal distribution. So this is a concept that's kind of beyond the scope of this unit, but it's good to look at. So moving forward now, we can kind of look at also some of the other parts that it came up. So again, the mean and the standard deviation, you have a mean age of 48 and a standard deviation of 13. So the dispersion here, you have basically there's variability. Standard deviation, and I explained this to some of you through the messages, that standard deviation is a good measure of variability of the graph of the mean. So it's not good enough just to look at the mean. It's actually more appropriate to look at mean and standard deviation to really understand on what's going on. So as you can see that there's Okay, so as you can see, this is where most of the age group is. This is close to the mean, but then the standard deviation is what makes this curve the way it is. So moving forward, now this week, this unit in Unit 4, all you were dealing with was the descriptive analyze and then descriptive statistics. That's all you were dealing with. You weren't dealing with anything else. So basically, some of the skills that we were looking for you to try to achieve were trying to understand if you can make interpretations from interpret mean, standard deviation, some of the central tendency measures, and also be able to look at the data and formulate appropriate quantitative analysis based questions. These were the main topics that were being assessed, and so I'm going to take a look at and of course be able to interpret some of this data when in your writing. This is basically what I will be evaluating you on, and I'll give you constructive feedback on how this was done. So another way that you can actually figure out the 95% confidence interval here is, thus far I showed you how to find out the mean individually, but if we want to find out the 95% confidence interval, there's a very easy way to do all of this, and that's with the Explore tab. The Explore, so the Explore tab, what it allows you to do is give you, with one fell swoop, with one click, gives you the 95% confidence interval, the mean, the standard deviation, and everything that I've been talking about thus far. So I'm going to click age here, and then statistics, I'm going to put descriptives with confidence interval for mean, and as you can see, it's right there. And then we can have the statistics, and then we can go ahead and plot that. So now, as you can see, the 95% confidence interval shows that it's between, the lower bound is 41.9 and the upper bound is 54.63. So if we look down and look at what the standard deviation is, it's 13. So now you can see that the standard deviation actually goes with that confidence interval. So there you have, with 95% certainty, you know that the data will be between 41.9. The age group will be between 41.9 and 54.6. So that this is a really excellent tool for you to use in trying to discern all of the different types of statistical all the different types of statistics that you were asked to do in this unit. So I hope this video helped. If you have any questions, again, feel free to contact me. And I'll give you further guidance as to what to do and how to do things. Thank you.